Hello and welcome to Space. This month we're going to take a close look at a mission that's trying to answer one of the toughest questions of them all. Is there or has there ever been life on Mars? But first, let's have a look at some other news from the universe this month. The ISS crew schedule has been rapidly revised after the Russian Progress resupply ship failure. ESA astronaut Samantha Cristoforetti now stays until mid-June. The next crew are delayed 2 months, and space tourist Sarah Brightman postponed her flight in September. Europe's only parabolic flight company Novispass has a new plane. The ex-German Air Force Airbus A310 will run regular flights from Bordeaux, allowing scientists to experiment in a weightless environment. To our main story now, and getting to Mars, landing there safely and then beginning the search for life is a huge scientific and technical challenge. Maurizio Capuano and Richard Bessudo are counting down to the launch of the world's biggest ever mission to the Red Planet. They're part of the huge team behind Exomars, a joint ESA and Roscosmos project to search for life on Mars. And the first spacecraft is almost ready.
This is Exomars 2016, which next year will land on the Red Planet. The lower part will go into orbit around Mars, putting out its solar panels to get energy from the sun. And the upper part is the lander, which will land directly on the Martian surface completely autonomously.
Exomars is split into 2 missions, the first in 2016, the second in 2018. This spacecraft is on a tight test schedule here at Thales Alenia Space in the south of France, and that's because it only has a narrow window of opportunity to reach its target.
To go to Mars, you have to wait for the right conjunction of Earth and Mars. And taking into account the orbits of the 2 planets, favourable conjunctions only happen every 26 months.
Once at Mars, the spacecraft splits in 2. The satellite stays in orbit and the lander heads for the surface. ESA hopes this test capsule will perform Europe's first ever controlled landing on Mars.
It has a form that makes you think of spaceships, of UFOs if you like, because the aerodynamic shape of the object is best to control the entry into the Martian atmosphere.
ExoMars 2016 will send back crucial information. Firstly, it will show how the lander performed. And secondly, the orbiter acts like a giant nose, sniffing the Martian atmosphere for methane. The gas could be a clue to the possible presence of life. Then, in 2018, the ExoMars rover will be launched.
How are the rovers going? ExoMars 2018 is really opening a new chapter in Mars exploration. For the first time, we will address the third dimension, which is depth. This is very important because it is in the subsurface and at depth that we have the best chance of finding evidence for the possible past presence of life on Mars.
Sending a machine to dig down into Mars is difficult. The very first hurdle is considered the greatest, landing safely. Then the ExoMars rover will need to gingerly find its way around.
We see here the prototype of the rover going down the ramps. This is more or less how it will happen in real on Mars.
The rover will aim for a landing site halfway between the Martian hills and the low-lying plains. It will look for places where water should be below the surface, and then it will drill down up to 2 meters.
The drill speed is quite low when you compare to the drill that you use at home, you say for homework. We have only the drill is operating with 50-60 watts, so it's the power that you use for a bulb lamp normally. and it's capable to do a great job because to dig a hole down to 2 meters and get a sample.
NASA's Curiosity rover has confirmed the habitability of Mars, so ExoMars will search for fossilized evidence of microbes and hunt for traces of organic molecules.
The microbes themselves would be too small to see. Their size is in the order of 1 to a few microns. So you would need a big fat microscope to be able to see them, something we don't have on our missions. But colonies of organisms can affect the deposition of rocks, and that we will be able to see. The other type of biosignature is organic molecules. And here you have to think of them as the Lego bricks of cells.
The ExoMars rover can also spot any present-day life on Mars, hidden beneath the surface away from harmful radiation. But is that possible? Do the ExoMars experts really think there's life on Mars?
It's, of course, a $100 million question. I'm convinced that there has been life on Mars.
I think it's quite likely that there is life on Mars.
Personally, I don't think there's life on Mars, but that's my personal opinion.
Golden, shiny things, it's really nice. I think there is a reasonable chance that there may be some pockets of life deep in the subsurface.
So the mission is underway to find out if there is or has ever been life on Mars. ExoMars could provide the answer by the end of the decade. To Cologne now, and our regular update from the Astronaut Academy, where we asked Andreas how you prepare psychologically to go to space.
0.06, range rate, target is known.
What do astronauts worry about? I mean, everything from the big to the small.
While you are in space, you have a lot of different pressure coming on your shoulders. The first one, I would say, is the schedule. It's very tight.
Our greatest pressure on us is that the science and technology experiments that we perform are performed successfully.
The second one is the risk. You are in an extreme environment. If anything goes wrong, it goes really wrong.
We really spend a lot of time almost memorizing what we're supposed to do in the event of an emergency. But we also worry about calling our family, talking to our friends.
Everybody will have ups and downs during this long-duration flight, but as a crew, it will not be at the same time, and the crew together can make it.
That's it for now. Next month, we'll have a look at the latest in rocket technology. See you then.